is derivatives of inverse functions. They have their own special rule that we're going to talk about. So, recall from previous courses that a function, y equals f of x, that is 1 to 1, will pass the horizontal line test and will therefore have a unique inverse function. So, if something passes, we did this last year in pre-calc, because my kids just tested on it. If it passes the vertical line test, it's a function. If it passes the horizontal line test, it has an inverse. Okay, and if it's both of those, it's what we call 1 to 1. Now, so we're going to talk about inverse functions, commonly written as f inverse of x. We often say the inverse function will undo the original function. This can be seen in the test to prove two functions are inverses of each other, since the composition of the two functions produces the identity function. Do you remember last year talking about f of g of x equals x and g of f of x equals x? That was one way to prove if Fogg and Goff both equaled x, then they were inverse functions of each other. Okay, well, that's what this is saying. This is saying if you take a function and what is supposed that it's inverse of each other, or inverse, it will equal x. And so that's what f of f inverse and f inverse of f are saying. Okay? A function g is often defined as the inverse function of the function f of g of x. What I just said here. If f of g of x equals x for each x in the domain, and g of f of x equals x for each x in the domain. G, okay, so it's very typical in calculus. They will start off in a problem saying, let the inverse be defined as g of x. Okay, so you have to watch for it. It's not just assumed, but so g of x is often denoted by f inverse of x. Now, and we'll come up with, is it the next page? I forget. There's a specific definition, page 3, I guess, so we talk about how to find the inverse of a function. Okay, so we will get to that as we go through notes. Reflective property of inverse functions. The graph of f contains the point a comma b if and only if the graph of f inverse contains the point b comma a. We've talked about this, yes? You have the inverse, or to get the inverse, you switch x and y, right? Okay, well, that is our reflective property. Now, in this example 1, we're just filling out some table values, if I recall. Use the reflective property of inverse functions and the function values for f and g in the table at the right to complete the table of values for the respective inverse functions, f inverse and g inverse. Then use them to answer parts C, D, E, and F. Okay? So, the table of values for f inverse of x. Which columns am I going to use to get f inverse of x? We're going to use the x and f of x column, right? If it's x and f of x up here, down here, it's then going to, yeah, the f of it. Basically, this is going to be f of x, right? And this is going to be x. So, take those columns and write them down. We're going to have the first ordered pair being 2, 3. -1, 1. 4, -1. So those are your f inverse values. What about g inverse?
-1, 3. -1, 3.
Hopefully you guys agree with her. Hopefully, do I agree with her? Okay. So for x, g inverse of x, this time you're going to use the x and the g of x column. So it's the g of x and then the x. You're just taking them and flipping them, correct? Okay. Use the tables to evaluate the following expressions. F of g inverse of 0 means what? F of So G inverse is here. G inverse of 0 is going to be equal to what? 1. Are you guys okay with that 1?
Yes.
And then what is f of 1?
Negative.
F of 1, go back up to your original column, and that is
Negative.
-1. You good?
Yes.
We like the easy stuff, right? If only it was all this easy. Okay, f inverse of f of -1.
Negative 1.
F inverse of 4. Negative
Is that your final answer, Doug?
4. Yeah.
1.
Now, let's go through the work.
Yeah.
F inverse. What is f of -1?
1.
F of -1 is
I got 4.
4. F inverse of 4. What is F inverse of 4?
Negative 1.
-1.
Oh my god, this is my brain.
Okay. Now, does it make sense how you can skip that work there?
Yes.
If you have a known function and inverse, they're just undoing each other. So notice we just went -1, it started at -1, then 4, we went right back to -1. So that is a valid trick, a valid shortcut. Okay, F inverse of G inverse of -1. Can I do it now? No, because they're not inverses of each other.
F inverse of 3.
She says F inverse of 3. Do we like the 3?
Yeah. It's 2.
Okay. So G inverse of -1 is equal to 3. F inverse of 3?
2. I think.
Right? And then it goes 2.
Yes. But
That's
that's
very
weird
hard,
though.
though.
Like it seems right, but it doesn't feel right.
But the 3 should be the input.
That's kind of what I thought too. Wait, what?
I should have looked at my answer key sooner. Okay.
One wrong.
No. Other than you're giving me the incorrect answer in the next step. Okay, so F inverse of 3. 3 is your input, which means I'm looking in the F inverse column. Where is there an input of 3?
There's no.
There's not an input of 3. So do we know what F inverse of 3 is?
No.
It does not exist.
No, I have it as undefined.
Danny.
Try this single word.
It's not defined in the
Yeah, they are.
They're very similar. Man, I was really like, oh my gosh.
I was really excited that I thought I did it. I worked ahead and got it right, and then I got it wrong. So.
Yeah.
G inverse of F inverse of 4.
G inverse -1.
Do we agree with her?
Yes.
Which was
Okay.
3.
3.
And then G inverse of -1.
3.
I can get on board with that one.
Hooray!
I was really panicky. I'm like,
So was I. I was like,
what did I do wrong? How did I do that so wrong? Whew.
No, I just did it so
Okay.
Yes. Same.
They threw a curveball at us.
I just forgot that it's possible to not have an answer.
What do you read?
Okay, next page.
Well, that's
So-
a lot of space.
It is, isn't it?
Why?
What we are kind of looking at here is we're working on figuring out the formula for an inverse. So, the existence of an inverse function. A function has an inverse function if and only if it is 1-to-1. And so, it has to have a function and it has to have an inverse. If f is strictly monotonic on its entire domain, either strictly increasing or strictly decreasing, that's what is it?
Monotonic.
How do we pronounce that? I don't know. I know, I kind of am trying to do the monotonic, yeah, I don't know.
Not Nick.
I know, I'm trying to do that. Maybe it's that. I don't know. Anyways, if f is strictly whatever, so either all increasing or all decreasing, then it is 1-to-1 and therefore has an inverse function. Okay, now, the relationship between a composite function and its inverse is stated below. This is what we already talked about, yes? If you take a function and put it together with its inverse, so compose them like fog or goth, it's going to always equal the x. It's always going to equal whatever your input is. If you use the chain rule and differentiate both sides, you can find a formula for the derivative of an inverse. And this is going to be a version of the formula that we use for derivative of inverse. Now, I think for clarity's sake, because writing F inverses, and derivatives all within there is going to get a little crazy. So, what I did in my notes is I started off and said, let G equal F inverse. In other words, I'm saying let G of X equal F inverse of X. So with that idea in mind, I'm going to take this right off the bat and rewrite it as F of G of X equaling X. And it'll be a lot easier. And then what we can do at the end is we can go back and put G and sub it with F inverse. Because let me tell you, it's no fun trying to write all the primes and derivatives together. So, we're going to take the derivative, and I'm going to write this out before I actually do it. I'm going to say we're going to do the d dx of F of G of X, and it's going to be equal to d dx, so the derivative of X. Okay?
What?
d dx just says, stating we're going to take the derivative.
No, you had brackets.
Oh, sorry. I didn't really say brackets out loud, did I? Okay, so what is the derivative of F of G of X? Derivative of F of something, F prime of something,
Times G.
times the derivative of the inside, which is G prime of X. Are you with me there? Derivative of F of something is F prime of something times the derivative of something, so times G prime of X.
Equals what?
Equals 1. Why did I do that? Yeah, we're just going to go equals 1. Okay. We're trying to find a formula for derivative of the inverse. So my question to you, what am I solving for? What am I trying to get this equal to? Derivative of the inverse. What's the inverse?
G.
G. So I'm trying to find G prime of X, yes?
Yep.
So how do I solve this for G prime of X?
Divide both sides by F prime G of X.
Do you see it? We're dividing both sides by F prime of G of X. Otherwise, if I say, okay, solve, you guys are going to be like, wait, I don't even know what I'm solving for. We're trying to find a formula for derivative of an inverse. Right now, my inverse is represented as G. So derivative of the inverse is G prime. Okay? Those cancel, right? I have G prime of X is equal to 1 over F prime of G of X. If we replace G with F inverse, then okay, hold on. I don't like how I wrote that. Oh my goodness. Okay, so when you write the derivative of F inverse, this is part of the reason we didn't do this all the way through, because it's already bad. I can't even write it. Generally, you write F inverse in parentheses and then put the derivative mark outside of it. So F inverse derivative
X.
of X, and it's going to be equal to 1 over F prime of F inverse of X.
All right.
Okay. Now, It's very careful, and I feel like, I don't know, I feel like my prime mark needs to be more angled here or something because it's almost looking like,
Straight up and down mine.
yeah. And this is, now, do you see why they often will replace F inverse with G?
Yes.
Because it just gets to be a mess.
Oh,
Okay?
this is a lot more.
So, very common for them to do that.
I don't understand why on the answer key she used y prime.
Instead of just putting in
dy dx.
Yeah.
I was like,
Y
why?
prime is quicker and easier to write.
But then you're
It's
still
so
end up
much
writing
more
dy dx.
I
You
know.
have to do it in the end.
You gotta pick one and stick with it.
Well, and I think what she's trying to say is that both work, be used to both, be familiar both. Even if you only use one, realize you could be reading something written with the other.
I said, well,
I
Amy
think
probably
she
was
was like
throwing both at
mid-problem.
once.
Not once within the same problem.
Oh, okay.
I mean, you might see one problem that has y prime and a different problem that has dy dx, but I don't think you'll see them within the same problem, if that makes
That could be-
sense.
That would be good for yours.
Yeah. Okay. Example 2, I believe, is we can use that formula there. Okay? Now, okay, we're going to try, but I'm probably going to get caught in the middle. Given a function, f of x equals 4x minus 3, and that f prime of 2 equals 4, find the value of f inverse of, I don't like how that's written. F inverse of 5, and then it says derivative.
The derivative of f inverse of 5.
Yeah, basically that is saying
Interesting.
f inverse derivative of 5. Does that look any better?
No.
Not really. But that's what it's asking us to do. Okay? Now, before we can do that, okay, so if we use our formula from the previous problem we just came up with was f inverse prime of x, I'll get it one of these days, is equal to 1 over f prime of f inverse of x. Okay, that is our formula from above, yes?
Yes.
And that's what we're going to try and use. Now, we're trying to find it for, instead of x, we want all my x's to be 5s. So what we're trying to find is f inverse prime of 5 equals 1 over f prime of f inverse of 5. Okay, so we need to know, start on the inside, right? When you see a bunch of parentheses, we know to start
Inside to out.
inside. So we need to know f inverse of 5. When you think f inverse of 5 equals something, yes? Well, what is that? What is that in terms of f? Does this make sense? Like, so the input being an inverse,
So that's x right there.
well, in other words, f inverse of 5, remember how do we, they switch, right?
So that's x in there and then 5's out there.
Okay, so if they're asking us f inverse of 5 equals what, we need to find f of what equals
So then you
5.
do 4x minus 3 equals 5, right?
Yeah, and usually they're something you can eyeball pretty easily because right there, yes, f of x is defined here. So yeah, 4x minus 3 equals 5, x equals 2. So that tells me that f of 2 is equal to 5, which means then that f inverse of 5 is equal to 2. So now I have 1 over f prime of 2. Can we find f prime of 2 pretty easily?
4.
So it's 1 over
Yep.
4.
Oh, because right here, guys, what is f prime? What is the derivative of 4x minus 3? It is 4, yes? So what is f prime of 2? It is 4. So this is 1/4.
That's what tells you the cycle.
What?
It tells you right there.
It tells you. The
Well, why did it tell me that? They should have told us that. Okay. We'll work more tomorrow.
Wow.
Sorry. I know I kept you over more than I usually do. My apologies.
That was really lovely.
we were all
You
laughing.
can't do the derivative because it's so.
kind of
But
waiting
isn't
to
it
see
easy
it or not.
derivative to find?
Yes.
So I didn't really expect them to give it to us. My apologies. My confusion.